Fill that on the table. Out some different aspects that a rational function has. First of all, what is a rational function? Do we know? What's a rational number?
What a positive number. Is that true?
What'd you say? That's an example of a rational number. That's an example of a rational number, but that's not the definition of a rational number. Positive whole numbers are types of rational numbers. Zeros included.
Real numbers. Yeah, I know. A number that can be divided?
We talked about rational exponents a lot in Algebra 2. What did that mean to have a rational exponent? It can be expressed as a fraction. So 2/1 or 2/3 or 1/2 or -5/4, anything that you can write as a fraction is rational. So whenever we were talking about yes and no. Pi is a real number, but it's not a rational number. It's an irrational number. Because you can't express it as square root of 2. It's irrational. It's not rational. But yeah. Square root of 2 can never be written as a fraction.
Okay, good. 2/1 square root.
Oh my goodness. All right, so when we talk about functions, we're talking about two different functions being divided. So maybe something like p of x divided by q of x or something, but there's a function on top of another function. In other words, a fraction. Looks kind of like the polynomials we've been dividing synthetically and long division kind of thing. Same concept here. The parent that we've talked about, we did the must-know functions, right? We've already done those. I'm getting so confused. Teaching these 3 different classes, I'm so confused on what we've done and what we haven't. All right. So we learned about one rational function, the parent function, called the reciprocal function. This one's the reciprocal. And it has please tell me when you're done, Carter. I know it fell, but y'all, that's what y'all were laughing about.
I was trying to prove that
all right. What does the reciprocal function look like? You're exactly right, Jackson. Good job. It's got the vertical and the horizontal asymptotes here. Okay, that's the parent. That's the most basic rational function that we know, but that is called the reciprocal function. But that is a rational function because it can be expressed as a fraction, 1/x. Okay, so let's talk about how we're going to graph some of these. First of all, tell me what it means to be an asymptote. It bounds a part of the graph, right? It doesn't have to bound the whole thing. I felt like you were looking at my feed. Okay. It wasn't like that, y'all. All right. Asymptote bounds part of the graph. It doesn't have to bound the whole graph. It can just bound a part of it. But it's something that the graph comes really, really close to, but it never touches. Okay. Asymptote, yeah. Just want to make sure you remember what it is. All right, so let's talk about some things that happen with rational functions. In fact, let's talk about some things that cause what we call discontinuities. Have we talked about holes? Yeah, we did. I remember taking a test on that. Yeah, we did. Top heavy, bottom heavy, same. Did we talk about that?
Oh, yeah.
Now we know. Tell me what a hole is in a rational function. So maybe I have whatever my rational function is or whatever the function is, but there's literally a hole in the graph, right? And we call this what type of discontinuity? No, jump is whenever you do. A hole is a removable discontinuity. Why do we call it removable? Well, you're exactly right, though. You can actually remove it from the equation itself. So, for instance, if I had f of x equals x minus 2 over x minus 2 times x minus 1. If that's my rational equation, right? Where is the hole here and why? Why? X equals 2 is a hole because I can literally remove it from the equation, right? But I still can't put 2 in there because it's going to make the bottom go to 0. And I can't have the bottom go to 0, right? There can be more than one hole. Well, but what happens there at the bottom? What does this become? That's your vertical asymptote. Okay, clearly y'all don't remember this. Okay. Okay, so then let's just go back and redo it now. That'll be for the best. That'll be for the best. Okay, when I have a rational function, I'm talking about a fraction, yes? Okay, a couple of things about it. When the top equals 0, those are my X-intercepts. That's where it crosses the X-axis, okay? I set the top equal to 0, and I solve. If you have factors that cancel out of the top and the bottom, they create holes. Factors that cancel. So in other words, in this case, it would be 2. Your vertical asymptotes happen with whatever's left that didn't cancel. You set the bottom equal to 0 and you solve. Okay, so it can't be a hole and an asymptote, it's one or the other. So in this case, in the case of the one that I'm looking at here, right? And it can't be a hole and an X-intercept. So this one wouldn't, this one's X-intercept because I've already taken this to be a hole. This one is not going to cross because it cancels out top and bottom. So if you can remove it from the equation, it makes a hole. So, and I can remove it, I can take it out, and this graph would look exactly like this one, but the only difference is it's going to have a hole or 2. Why wouldn't there be what? There's not a hole at 1, there's a vertical asymptote at 1. Different than a hole though, because a vertical asymptote is not removable. A hole is removable. You can't algebraically remove it from the equation. Look. On the graph, this, whenever you graph this, it would look like this. There would be a vertical asymptote at 1, and then it would do this. No, but there's a hole. 1, 2, the hole would be right there. You wouldn't be able to see it on your calculator, you just have to know. So it has 2 discontinuities. It has a vertical discontinuity, an infinite discontinuity, and a hole. It's got both, and it can have both. I'm sorry. Now, as we get further in our math career, we don't count the asymptote this way as a discontinuity. We say that that's not in its domain, so therefore it's continuous on its whole domain. We'll get to all that. For right now, infinite and whole. Okay? Y'all okay? All right, look at this one. Here's what I want you to tell me. I want you to tell me three things. I want you to tell me any X-intercepts. Actually, I lied. I want four things. Any Y-intercepts. Then I want you to tell me any holes and any vertical asymptotes. No? Don't worry about horizontal asymptotes right now. We haven't talked about that again. Just vertical asymptotes, holes, Y-intercept, X-intercept. Do y'all want me to define that first and then we'll just do it all on these? I was trying to take it a step at a time here. Okay, X-intercepts first. Well, actually, before I do X-intercepts, I need to make sure nothing cancels. Because remember, X-intercepts happen when the top equals 0, but ignore anything that cancels. What is? Don't worry about that right now. We haven't talked about that yet. Just wait. When the top equals 0. Because that's how you find zeros. You say, when does the function equal 0? Well, the function can only equal 0 if the top 0. Because if the bottom 0, that gives me discontinuities and undefined point. How about the Y-intercept? How do you find that? Tell me what you're doing. How do you find a Y? What if I had the equation, what if I had a regular old polynomial? F of x equals, or a quadratic even, 2x squared minus 3x plus 7. What's the Y-intercept? What did you do? Y, is that what it is? Yes. X equals 0. X equals 0 for the Y-intercept, Y equals 0 for the X-intercept. Okay? So what is the Y-intercept here? -5. Right? 0, 0, -15, 0 plus 3. So -15 divided by 3 is -5. But that cancels, so it's just, yes, so ignore that canceled one and just look, x minus 5 equals 0. All right, how about holes? X equals -3 because that's what canceled. I could remove it from the, if I can remove it from the equation, it creates a hole in my graph. How about vertical asymptotes? -3. So you're telling me you got a hole and a vertical asymptote -3? None. We took it out. That's right. We took it out, so it's not there anymore. It can't be a hole and a vertical asymptote. It's one or the other. And if it's already a hole, then, well, nothing. So this is just, if you graph this, This is nothing more than the line x minus 5 with a hole at -3. It literally will do this with a hole. That's it. And horizontal asymptote. Learn is a loose term because we've already done it one time. All right, horizontal asymptotes, and then we'll do some all together. Say it again. Yep. Yep. Do you know what each one does, though? Top heavy. What do you mean by top heavy? And what are we looking at? What are we comparing? Exponents. Which exponent? Assuming that it's written as standard, the biggest exponent. The biggest exponent. The biggest exponent. Top heavy. Where's the asymptote? Horizontal, so I'm y equals. Where's the asymptote? None. How about bottom heavy? And how about same? That's right. Leading coefficient of top divided by leading coefficient of bottom if they're the same. This is a huge deal in calculus that some of us still struggle with. Precisely. He's really smart.
What is he going to think?
Find the X-intercepts, the Y-intercepts, vertical asymptotes, horizontal asymptotes, holes, that's it right now. Good do what? Always factor. What does that mean? Oh, did you say no zeros? Yes, it means no zeros. I'm sorry. Carter, where's the X-intercept? None. How about the Y-intercept? None. That's right. How about vertical asymptote? Which means no, that's horizontal. We're talking about vertical. All right, listen, vertical asymptote is where the bottom is 0, but factors don't cancel out. So where is x squared equal to 0? Well, square root is x equals 0. It canceled, that's a hole, so I can't count it twice. Horizontal asymptote, bottom heavy. X-intercept is where the top equals 0. But you can't count something you've already removed. You removed the holes, so you can't count those. So there's no X-intercept. If you plug 0 in for every X, you get 0 minus 1 over 0 minus 0. Yeah, so it's undefined. What do you think this looks like when you graph it? Yes. I know I've got asymptotes. Well, let's think. At 1 squared is 1, so 1 over 1. So it's got a hole at X equals 1. So here's a hole. So if I put in, let's say I put 2 in, what would my Y value be? If you put a 2 in for X, why don't you just use this equation? You still got it. So it's actually going to look, right? And then the same thing over here. Yep. I just got to put in enough to pick up the pattern, really. And I know where the asymptotes are. So I don't think we did a whole lot with like actually graphing them. We did some analysis of them, but we didn't actually graph them. So I knew there was a hole at 1, so I put that hole at 1. If I plugged in 1, that's what I got. So then I said, well, what? I know their asymptotes are here, and I know in general what rational functions look like, but if I plug in 2, what's going to happen? And I'm going to use my simplified equation. Mac likes to use this one before we canceled anything, but yeah. But I just plugged in a couple values, and I said if it's 1 over x squared, then if I plug in 2, I would get a 4th. If I plugged in -2, I would get -1/4. So these are doing the same thing on either side. And I just had to know to put the hole there. Yeah, pick some values. Generally, at least 2 points on either side of every vertical asymptote will give you enough. If not, if you can pick it up and you know what it's going to look like. But sometimes sometimes you'll have some rational functions, and you've seen these, that do something like this. So you just have to be able to pick up enough to pick up the pattern. What's the domain and range here on this one? You were right. How about the range? Because you got asymptotes at 0. Oh, you're right. Guys, Noah, you are majorly distracting me. And now from what to what? Why do y'all keep saying 2? 0 to 1. Because I'm just leaving the 1 out because it's a what? A hole, thank you. And then 1 to infinity. And then range. One more and then I'll stop.
Wait.
I don't think mine required any.
Well, that's not my fault. My teacher left. My teacher left. They can take that up with the students.
I never knew what I wanted to do. I just, by the time I got into started my third year, had to declare a major. No, what? Okay. And my part's Spanish. Not necessarily in this order. Domain, range, X-Intercepts, Y-Intercepts, vertical asymptotes, horizontal asymptotes, holes, and then the graph. Y'all don't know how to factor?
That's like the only thing I've learned.
I don't even know how to factor that right now.
Okay, side note.
I wouldn't even know what to do with that.
Yo, what did you do in Algebra 2?
I used to know how to factor, but now I don't.
It is better than that.
Negative 2 and
All right, so here, let me just run you through quickly if you don't know how to factor. You multiply the first and the last term together. So together that gives you what? Positive 24. Positive 24x squared, right? And then you're going to find two terms that multiply to give you 24x squared, but they have to add to what's in the middle. They have to add to negative 14x. 8 plus 3 is 11. Keep going. They multiply to positive 24, but they add to negative 12, right? Negative 14. Then it can't be factored, which is possible. You might. Okay, so 3. Just because you know how to do this, Carter, doesn't mean. I'm going to rewrite this using those two factors. Okay, and now I'm going to slash it in half, and I'm going to look at this as two separate problems. What is the GCF of 3x squared and negative 2x? X. 1x. If you take an x out of these, what's left? I'm going to keep the middle sign, and now I'm going to do the same thing. What's the GCF here? In other words, biggest thing. Carter, she's trying to understand this. Negative 4. If you take negative 4 out of here, it should leave you with 3x. Remember, I'm taking out negative 4, so I need to change this last sign because I'm dividing by negative 4. Now, you should get to the point where these two parentheses match exactly. When they do, you write that one time and write what's left as the second part, x minus 4.
Yeah, somebody. No, it was just y'all.
There's other people who are silent right now who don't know how to factor.
It's only you.
I promise you.
Who does know this factor?
I know you don't know how to
Okay, on the bottom, same thing, different problem. We are. So what multiplies to negative 4x squared but adds to negative 3x? What'd you say? What is 4x2? Oh, 4x squared. Yeah. Okay. So what? Two x and 1x multiplies to 2, not negative 4 and positive 1. Write it in and slash it. So I've got x squared minus 4x plus 1x minus 4. Now let's factor each piece. Biggest thing I can take out of the first two, you're right, would be x. What does it leave me with if I take an x out of those two? Plus, what can I take out of these two? 1, and what's it leave me with? I don't think they need the shortcut right now. All right.
I thought we already did it.
The domain is left to right, so the vertical asymptote impacts the domain. Horizontal asymptote impacts the range. All right, so this one I'm going to... I'm just going to carry on. All right, guys, I'm fighting for your attention now. All right, so f of x now becomes 3x minus 2 times x minus 4 over x minus 4 times x plus 1. The very first thing I'm going to do is find my holes. Shut up, Carter. Carter. X equals 4 is a hole. How about vertical asymptotes? Because that's what I want to look at now. Negative 1, because that's the rest of the bottom equal to 0. How about X-Intercepts? All right, listen. Y'all have got to listen. X-intercepts happen when the top equals 0. But I don't use what I've already taken out. I've taken out the x minus 4. So when does 3x minus 2 equal 0? 2/3. Add 2, divide by 3. Y-intercept. Negative 2. How did you get that? Plugged in a 0 for x's, right? 8 divided by negative 4. Or negative 2 divided by 1. Whichever one you want to do should give you the same answer. Horizontal asymptotes. 3. Why is it 3? They're the same, so it's leading coefficient at the top divided by leading coefficient at the bottom. Okay, well, let's graph it. So I need to graph it first and look at it, and then I'll tell you. You can, but it's a little harder. Okay, well, let's look at it. Let's look at it. I know that I have vertical asymptotes at -1, horizontal asymptote at 3, 1. I'll worry about my whole last. I always worry about my whole last. Y-intercept of -2, X-intercept of 2/3. I can already tell without doing anything else what this one's going to do. Do you see? What's it going to do? Which means this one over here is going to do the same kind of thing. I need to make sure I put my hole in here, and the hole is happening at 4. So around right here, there's a hole. If you put this on your calculator's not going to graph the hole. So my x-intercept and y-intercept were my points. This is the x-intercept, and this is the y-intercept. Now, domain and range is what you asked me. So domain is left to right. So -infinity to -1. Then I pick up at -1, and I go until I get to that hole at 4. What? Well, this should be the point 4. I don't know what the other part of the point is, but I'm going to find it in just a minute. So I'm going to go until I hit 4. I'm going to stop. I'm going to pick back up, and I'm going to go 4 to infinity. Now, I told you I had to find the other part of that hole, and this is why. My range is going to go from -infinity up to, I need to find that because that's the first thing I leave off. So how am I going to find that part of the hole? F of 4 means plug 4 into your equation. But I'm going to use this equation, the easier equation. That's exactly right. So I'd get 12 minus 2, which is 10, and 4 plus 1, which is 5. So this point is actually 4, 2. I will. So I'm going to go from -infinity to 2, 2 to 3, and then 3 to infinity. Okay. Okay, so range is from the bottom up. So the lowest I ever go is -infinity. And then I go up until I hit this hole right here. And because range, Carter. Guys, why is what at 4? There's a hole at 4. All of this comes into play with my domain and range. What? It doesn't. The asymptote is at y equals 3. There's another piece up here. You see it right here? Yes. So the big thing here is pulling this all together for the graphs, and it looks like our domain and range is showing. Don't pay me. All right, I'm going to stop. I don't know how to get my recorder to stop. I have a sheet for you for your homework. Well, I'm not going to have a recording for today. My recorder's not been working today. Hold on, I give it to you. Y'all are not good today.
There was a lot.
There was nothing new. My best ever catchphrase up tomorrow.
Block out.
I can't believe I forgot that.
Block out.
So there's no Y-intercept is where zero is from. All right, well, I'm sorry, y'all, but we're going to get. We don't have a benchmark in here. I'm so sorry. In your class. So there is no hole. There's nothing here.
I made a.
Put your asymptotes on there. So it's going to be on the other side too. It's going to look like the wings, like the reciprocal function looks. It'll just mirror it.
Like this? Like going that way?
Yeah, and then you'll have another one up here doing the same thing.
Get a copy with zero.
For what? Why'd you leave zero out? On the main.
Because it stops it. Oh, I don't know.
Yeah.
It would just be negative.
Other than that, yes. Yeah. So you're going to come and do the little wings here. Just pick a couple points to play. That's fine. That means it crosses over here.
Wait, so the Y-intercept is divided.
The top equals to zero. You have to add.
So the Y-intercept is If it's like positive 0, how do I, what do I put? 0. No. The Y-intercept.
The Y-intercept is when you put 0 in for
I know,
X.
and the bottom.
So it doesn't have one. That's
No
undefined.
Y-intercept. Oh, because
What about the vertical?
okay, that makes sense.
There's an S on the bottom. The vertical after the is 0? Or is it not?
Yes, 0.
What is it not? What is there not a vertical aspect?
When it's, the bottom could never be 0.
Like, what's an example?
I don't think we're talking about that.
Where you don't have a vertical asymptote. So if everything canceled, like the very first one we did,
Okay,
where I said it'd be a line if you graphed it with a hole in it, because it canceled outside and bottom, but it just left a factor in the top. That would be one that didn't have a vertical asymptote. So which one? Vertical's up and down.
Oh, it should be negative 1. Yes. And then this one would be
See if I'm doing like this one right while I'm doing it.
Yeah.
Wait, Miss, you don't have any?
Yes.
Don't have any?
Some of them don't have it.
I know, but X is negative 1. But, yeah. I'm gonna get my eraser out so I can put my lead back in. Yeah. I'm sure the one thing is because after school, yeah, that's wrong. I always do before.